Hey everyone, it's Justin again. Welcome to the help video for the first problem in your parallel and perpendicular lines part 2 activity. This problem says, what is the equation of a line in standard form parallel to the line y equals 3 halves x minus 7 that goes through the point 3, negative 12? From the previous lesson, we know that using the parallel, slope, and a point on the line can help us to write our equation in point-slope form. But this problem specifically says to write the equation in standard form. What are some differences you see between the equation we have and the way standard form is set up? You might be thinking, there are no parentheses in standard form. Or that in standard form, the x and y terms are both on the left side of the equation. You may also remember that the a, b, and c values in standard form need to be integers, and a needs to be positive. These are all things that we will keep in mind when changing this equation into standard form. So let's get started. First, we can distribute the 3 over 2. This gives us 3 halves x, and 3 halves times 3 equals 9 halves. Now that we've gotten rid of the parentheses, let's get the constant on the correct side. We'll need to take negative 9 halves and subtract 12. In order to subtract fractions, they need to have the same denominator, so I need to rewrite 12 as a fraction with a denominator of 2. 12 is the same as 24 divided by 2. Now that the denominators are the same, I can just subtract the numerators. What does negative 9 minus 24 equal? Yep, negative 33. Also, remember that the denominator does not change when adding or subtracting fractions. So we have negative 33 over 2. And hey, look at that. Our equation is now in slope-intercept form. If this is the form we were asked to find, we could just stop right here, but this problem specifically asked for standard form, so let's do a little more manipulation to get there. Remember the goal here. We need to have the x term first on the left, and we'll need to make sure that a, b, and c are integers, with a also being positive. So let's subtract 3 halves x on both sides of the equation in order to move the x term to the left side. Now we need the a value to be both positive and an integer, neither of which is true right now. So what can we multiply this fraction by to make it a positive integer? Multiplying it by 2 would cancel the denominator, and multiplying it by negative 2 would also cancel the negative sign, since a negative times a negative makes a positive. Now that we've decided what to multiply by, let's make sure we apply it to every term in the equation to keep it balanced. If you made a mistake at some point, take a moment to pause this video and practice distributing this negative 2 on your own. Remember to distribute it to every term in both the left and right side of the equation. Negative 2 times negative 3 halves x gives us 3x. Negative 2 times positive y is negative 2y. And negative 2 times negative 33 over 2 is positive 33. Let's take a moment to compare these. Would you say we've gotten to standard form? Yeah, we have the x term first, y term second, and the constant on the other side. The a, b, and c values are all integers, and a is also positive. So we've got our final answer. Don't forget to go back to any parts of this video you'd like to see again. And remember, I'll be ready to help you in the other help videos if you ever get stuck.